Hey guys, gals. So today we're going to go over some notes on electrical charges. So this is going to be part one out of three. So we're going to do some notes Monday, Wednesday, and Friday. Now there might be a possibility that I'm absent on Monday, so we might do this. This might actually be Tuesday's lesson, but that's okay. We'll figure it out. So today we're going to do part one, which is going to go over the first few slides and talk a little bit about what are electric charges, and then actually kind of show some little gizmos and things like that as well. So, all right. So very first thing, plan for the week. Note that on Monday today, again it might be Tuesday. We're going to go over through the first couple parts, and then we're going to do an activity part A, and then kind of come back together at the class. If we do not finish the activity or wrap up, consider that homework and you have everything you need. You have the notes, you have the links, everything's on Canvas, and you're in class kind of checking these out. So you have everything that you need for that. All the work that we do for the week will be due on Friday. So you can kind of go at your own pace as well, but we will be working on it during class time. Okay, I'll give you time to make sure you complete everything. All right, so remember there's going to be a weekly quiz on Friday, and so remember things that can show up are things from this PowerPoint, things from the activities that we do in class, information that are coming in our question and answer session at the end of the wrap ups. I actually had some questions on this document, so those are some of the questions you can think about to get ready for your quiz. The quiz will be randomly generating things for you. Then it is locked. Okay, right now the quiz is locked. It will be unlocked Friday morning. Then again, I will give you time during class on Friday to actually do that quiz. So, all right, so today we're going to talk about electric charges today. And so the most important thing that I can kind of get through to you today is that, and probably you already know this, but is that charges of the same magnitude or the same type will repel each other, and charges of the opposites will end up attracting to one another. So electrical charges. So electrical charges can be positive or negative, and so that means that they're going to have regions or areas that have the quality where they are positive or negative. And we'll talk a little bit more about what that actually means. It kind of means what's happening to the particle, what kind of field are they generating, is it going to be positive? Is it going to be negative? So in this picture here, you see the very first two. You have two positive particles that they're not going to come close to each other. They're going to move away from each other. You have two negatives, same thing. They're the same. They're going to move in opposite direction. And then then you have the opposite charge, positive, negative. They're going to be attracted to one another. You probably have already heard that term, the opposites attract, and like repel. Um, so again, we're starting with the basics, talking a little bit about charges and electricity. Also, please remember that atoms have charged particles. Okay, all atoms have two charged particles in them. They have the positive proton, and they also have the negative electron. Right? Look at the model there in the picture. The protons and the neutrons are in the center of the atom. The neutrons are neutral; they do not have a charge. Okay, so they do not exhibit any field characteristics with electrical charges. So we have the proton and the neutrons in the middle. Okay, so here's the question for you to think about: how or why are all those positively charged protons being kept together in the middle? Wouldn't they want to repel each other? The answer is yes. They do want to repel each other. So how is it that all those protons can be stuck in the middle of the atom? Well, it has to do with another force. It's called strong nuclear force, and the neutrons are there holding all the protons together in a tight, dense nucleus. It actually took scientists a really long time to figure this out because it just didn't make sense. It didn't make sense that a bunch of protons be packed together in a small area until we got more experimentation, more data, and better technology that they're able to kind of figure out that the neutrons are actually holding those protons together and kind of very similar to gravitational attraction where the proton and the neutrons are kind of stuck together, and that's called strong nuclear force. Eventually you can't get too many protons, and doesn't matter how much neutrons you have in there, and the atom will simply break apart, and that's called radioactive decay, and that is very, very common for radioactivity. Okay? The neutron or the electrons are negatively charged. They're flying around the outside of the atom. Note that they're not falling into the protons. They're not collapsing into the protons. And that's a good thing because that will end up creating a nuclear reaction, nuclear change when a proton, neutron, and electron get together. The electrons are moving on the outside of the atom almost the speed of light. And so essentially, they're moving too fast to collapse in with the proton. But they are attracted to the proton, so they are staying together as an atom. Okay, so without these attraction, we wouldn't even have atoms. Without atoms, wouldn't have matter. We wouldn't be here at all. Nothing would be here. Okay, so these electrical charges are very, very important. All right, so the other idea here is that matter in general can become charged. We can actually charge up different types of matter. So objects can change their charges when they lose or gain electrons. Now that's important. We're talking about electron moving and going places here. Electrons are negatively charged. So if I take electrons away from something, that object is going to become less negative, or another way of saying that would become more positive. Right? So if you remove electrons, become more negative or become more positive. If you add electron to something, that item will become more negative. Okay. Or become less positive, depending on how you want to talk about that. So there's a quick little demo here, and I want to show you that. So I'm going to pause the video real quick. Okay, so we are back, and now we are taking a look at a quick little demonstration. This is not a gizmo; it's actually a FET, which is actually pretty cool. You go to this website down here, type in FET, you guys can see some cool stuff, cool demonstration. So here we have a balloon, and you guys probably have done this before, where you take a balloon, you rub it on your head, and you're charging up the particles of the balloon and also your hair. Then your hair does, frizzy, wild thing. Same idea. This is what's going to happen here. So we have a balloon. Note that everything is neutrally charged. Same number of protons and electrons. Okay, so they cancel each other out, and they are neutral. So, so what we could do though, we take this balloon over here, we can start rubbing it on the sweater, and note that the balloon is removing electrons and is adding the electron to the balloon itself. So the balloon is becoming more negative. The shirt is becoming more positive or less negative, and note all the protons that are on that shirt. So what's going to happen when I let go of the balloon? Well, it's going to get attracted to that sweater because, again, opposites are attracted. So the balloon is negative, the shirt now positive. They will attract one another. This is what happens to your hair. Your hair gets pulled to go to the balloon, and that's because your hair is now positive, the balloon negative. So your hair wants to go and run out to that balloon. We also can take this balloon and we can actually move it to the wall. Now, what do you think can happen as I move it to the wall? You might have saw it already. Well, this is negatively charged. It's going to repel those electrons in the wall. It's going to make those electrons move. So check that out. So when those electrons move, note that that part of the wall becomes more positive. The balloon is negative. That part of the wall is positive, and then the balloon will be attracted to the wall. Okay, you've probably done that before. Now, we are not removing electrons or anything from the wall itself in that situation. We are inducing a charge on the wall by moving those electrons, causing those electrons to kind of go away for a little bit. So this balloon can be attracted to neutral surfaces like the wall, or it can be attracted to other surfaces like the sweater. Let's see if we got another one in here. If I add some protons to that. So note that the balloons don't really like each other. They're kind of fighting each other a little bit here. See how that balloon kind of dodges it. Wants to stay away from the other balloon because both balloons are negatively charged now, and the two negative charges are going to repel each other and move away. All right, let's go back to the notes real quick. Okay, so that phenomenon that we just were taking a look at with the balloon being attracted to the wall is called an induced electric charge. So charged objects can be attracted to neutrally charged objects. And what that's going on there is that, again, you're causing the electron to move around. And then, therefore, the charged particle can be attracted to neutral objects. So the protons and the electrons are still balanced, there's still the same number of them. But because you're moving the electron and the protons away from each other because of the charges, that you can actually end up creating an induced charge. Okay. So shard particles can attract to neutral objects in that way. Okay. All right. So we talked about positive and negative. How do we know something is positive? How do we know something is negative? Well, protons and electrons, we kind of all take that for granted that we just say protons are positive. Well, how do they know they're positive? Well, it has to do with the field. So all shard particles will create a field around them. And remember that field is a force, but it does not need to touch each other. Remember, there's a difference between contact forces and field forces. So electric charges are in a field around the particle. And then depending on what is happening, how the field is acting, we can tell if it's positive or negative. So if you look at the drawing here, positive field will emit from the object to the outside, okay, and go kind of away from the middle. Whereas the negative fields, the field will kind of go toward the objects themselves. And so you have this invisible field, you can't really see anything, but there are the lines, there are actions, there are things that are happening. And so a positive field will go away from the object, a negative field will go toward the object. That's how we know something is positive or negative. And so if you look on that drawing here, this field, you see the attraction. That positive is going to go away towards the negative, and they want to be together because that's exactly what it wants to happen. The positive wants to it forces to go out, and the negative wants its field forces to go in, and so they're going to be attracted to each other because that's exactly what wants to happen. Whereas this positive, these positives, they both want the forces to go away from each other, so they don't want to interact with each other. Like, no, 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 get your force away from me because I'm positive. Okay? And so note that the electric field moves outward from positive and inward toward negative objects. Okay. Hopefully that makes sense. And that kind of explains a little bit how we know things are positive, negative, and how they react with each other. All right. So remember, and these are called field forces. That if you put a positive particle inside of a non-zero electric field, that a force will act on it. So if I have a field and it has a charge in it, say it's negative charge, and I put a positive in there, well, that positive is going to like the negative charge, right? If I put a positive through a positive field, okay, well, it's going to repel each other. Okay, so if you have an electric field and you put a charge through there, a force will be acted on it, and that's again without touching. Those are called field forces. Okay, if the charge moves, the electric field will be doing work on that object. Okay, so today we're actually going to investigate that by using what's called a charge launcher. We're actually going to launch charges through an electric field that you're going to design, that you're going to make up and do some challenges with. Okay. So there are some additional resources. I would encourage you to watch them to kind of help you out with your quizzes on Friday. These are good videos. These are good articles that I found that I think will help. I've also took some of the pictures and some of the ideas from these articles as well. So I do highly encourage them. All right. So today's activity, whether it's Monday or Tuesday, we are going to do the charged particle and electricity part A. We are going to do a breakout group, and in Microsoft Teams will automatically break you up into random groups, and then I will be able to watch your groups as you guys work. I can be in and out of your groups. Even if I'm out of your group, I can still see what you're doing in your group. So be mindful of that. I'm going to give you about 10 minutes to work on that. Even though you are working together, your answers must be your own. Okay, there's no copying, there's no sharing of work. You must answer your own questions, your own work. Okay, so it's really important. Okay, we got to be respectful of those norms. We're not copying things word from word. Okay, I'll give you about 10 minutes to work with your partners and help each other out. I also made a video for this gizmo that you're about to do, and kind of showing you how to use the gizmo. I really want you guys to watch that video first. Then you can go off and do the activity, do the gizmo once you understand it a little bit more, a little bit better. Today's gizmo is pretty easy though. You're going to shoot a positive or a negative through a field that you make, and then see what happens to it when you put other particles in there. All right. As always, you guys have questions on any notes, make sure you let me know. After you do the activity, there are some questions, Monday's recap, that we will going to kind of go over. Again, if we do not have time to go over those questions, consider them homework to help you study for the quiz on there. Okay, so I've asked you those questions here, so take a look at them. Do them. Okay. Don't just ignore those questions. They're going to help you out on that. Okay. And then, of course, as always in class or email or whatever, please make sure you ask me any questions that you have. Okay. And I'll do my best to answer them. All right. Thanks, guys.